Hello students, my name is Sumit Mehta. So in today's lecture, we will discuss about what is power of I, okay, and we will also find out the square and some identities on the complex numbers. Okay, so first let me tell you, iota is, as you all know, that it is root of minus 1. So iota square will be minus 1 and iota cube will be minus 1 into then again iota, so it is minus iota, and iota 4 it is iota square square which will be minus 1 square as 1. So these are four important numbers which we have to find out. Okay, after that it goes on repeating, like iota 5 I have to find out. So can I write this iota into iota 4? So this iota into 1, which is iota. Okay, so this after goes on repeating, so iota 6 will be iota 2. Okay, and iota 7 will be iota 3. So can I write iota ki power 4k is always equals to 1? So student, these are some identities which we will be using in further questions. So iota power 4k is always equals to 1. Okay, and iota power 4k plus 1 means, so it will be always iota, and iota power 4k plus 2 it will be always minus 1, like these, and iota power 4k plus 3 it will be always minus iota. So these are the four identities which you should remember to solve the questions. Okay, so now let's discuss about some identities also. The first and the foremost important identity is z1 plus z2 whole squares is equals to z1 square plus z2 square plus 2 times z1 z2. Okay, this we have to prove. So first I will take the left hand side. So left hand side is given to us as z1 plus z2 square whole square. So it is, can I write z1 plus z2 2 times? Okay, now use the distributive property, means if it is multiplying with both these, so can I write this as z1 plus this as z2 by using because distributive law. Okay, so now simply multiply, this is z1 square plus z1 z2. Now it is also z1 z2 plus z2 square. So now using the commutative law, it is coming out to be z2 z1. So z2 z1 is also equals to z1 z2. I can write z1 square plus z2 square plus 2 times z1 z2 using commutative law. Commutative law of multiplication. Okay students, so similarly this is the first formula. Similarly we can also prove that z1 minus z2 square is equals to z1 square minus 2 z1 z2 plus z2 square. The third identity is z1 plus z2 cube, which is, so these are the same identities which are same as the other real numbers. Okay, z1 cube plus 3 times z1 square z2 plus 3 times z1 z2 square plus z2 cubes. So student, there are more identities based on these. Okay, so these are some important identities. So z1 minus z2 square, this also equals to z1 plus z2 into z1 minus z2. Okay, so these are the important identities and the power of I that I have discussed in this lecture. Okay, and in the next lecture we will do some question based on these identities. Okay, so stay tuned for the next lecture on question based on these identities.